Let's try using Newton's second law to analyze the motion of this lawnmower here. Suppose that the net external force, which is our pushing minus our friction, we're not worrying about the individual forces, we're just saying the net external force that this lawnmower feels, is 51 newtons parallel to the ground. The lawnmower has a mass of 24 kilograms. So what's the acceleration of the lawnmower? We start by drawing a free body diagram of the lawnmower. We'll have some axes, x and y, and then we'll include the object and the force acting on it. Again, since I'm not a great artist, I'm just going to draw this lawnmower. It has this dot and call it a mass m, and then we'll say that the force that's acting on it is that 51 newtons in the x direction. So I can write Newton's second law from this. I know this is very simple, and you could probably have just skipped to writing F equals ma here. I'm showing you the free body diagram because for more complicated things, you're going to want that, and we're going to use the free body diagram to write our Newton's second law statement and figure out what goes where inside of that. So here we have the vector expression. My net force is equal to mass times acceleration. I'll now look at the x component of that. Again, there's no y component that matters here, but in case there is, considering the x and the y separately can be useful. So here we'll say the net force is all acting in the x direction, and that's equal to mass times acceleration in the x direction. We can now solve this for my acceleration in the x direction by dividing both sides by the mass and plugging in what we know and solving for it. And so we get an acceleration of 2.1 meters per second squared. When we're reporting an acceleration, it's a vector quantity, so we need a magnitude and a direction. So this will be 2.1 meters per second squared as the magnitude, with the direction as the I hat direction if you're using this I hat vector notation. Or you could say a rightward arrow to express that it's 2.1 meters per second squared to the right.